Excuse me. You need to see anything from 7.4? Arc length and surface area. We have 3 things, questions from 3 things. 7.4 homework, that worksheet 1 through 20, and then the chapter 7 review. So anything from 7.4. All right, what about the 22 actually? Did we find all the typos there were? I think number 20, I found, well, Jesus mentioned it to me after class Thursday. That was just a typo. I think it said 2/3 and it was supposed to be 32/3. I emailed you about that. Anything else from those?
Can we see number 2 from the chapter 7?
Mm-hmm. Absolutely. So this page is good. All right, chapter 7 review, number 2. And by the way, when I was doing number 27 last night from the chapter review, the length of the catenary, I was going, please let them know I don't mean this to take them an hour like that. That one was terrible. And when I finally looked at the solution, it said by Simpson's rule. And I thought, no, surely y'all knew I didn't mean for you to do Simpson's rule. That's all right. It was still ugly even with the calculator. All right, number 2.
I did with the art. What was supposed to happen?
I don't know, that you had to find the derivative on number 27 and then put it into the arc length formula. It was pretty bad.
The one that I did was the 7.4.
Oh, okay. Number 2 just says find the area between y equals 1 over x squared, y equals 4, and y equals 5. So we're just talking about a little bitty piece of area. And I know what 1 over x squared looks like. It looks kind of like 1 over x, but because you can't get a negative from it, both pieces are in the first and second quadrant rather than first and third quadrant. Wait, first and second quadrant? Yes. You can use negative x's. You're not going to get negative y. All right, so kind of looks like this. And when x is, I gotta get my brain working this one. When x is 2, y would be 4. And y equals 4, y equals 5.
I think that's supposed to be x equals 5.
Oh, that would make more sense. Yep. X equals 5 is over here somewhere. So we're looking for the area bounded by that. 1 over x squared, y equals 4, and x equals 5. What?
Got that wrong.
What did you do?
I did the area under it.
Ooh. And you have to watch out for that. I made that same mistake on a different problem yesterday. But if it says bounded by y equals 4, it's up to y equals 4, not below that. How do you find your bounds of integration? The what? Yeah, they're X values. So I know my top bound of integration is going to be 5, but what about that bottom lower bound of integration? Yeah, it has to be the intersection of 1 over x squared and 4, and that's when x is a half, y would be 4. And then make sure you're saying upper bound is 4 minus lower bound is 1 over x squared. So that would give it to you. What else?
Number 4.
All right. Got to make sure that you can graph a sideways parabola.
I was able to graph it, I just don't know the shading is what they're asking for.
All right, let's look at it. X equals -1, y equals 0. All right. To get the vertex of that parabola, I would complete the square, add 1 and subtract 1, and then factor that perfect square trinomial. And what's the vertex of that parabola? It's opposite of the guy in parentheses and the guy on the end, except for the guy in parentheses is the y coordinate of the vertex. So that vertex is at -1, +1. And -1, 1. It's a parabola that opens to the right because that leading coefficient's positive. If you let x be 0 to get the y-intercepts, when x is 0, y would be 0 and 2. So that's just 2 more points on the sideways parabola for you. And you want the piece of graph bounded by that, and x equals -1. Here's x equals -1, and the x-axis. So do you see which little piece is bounded by this parabola, this vertical line, and the x-axis?
I just had a graph.
That piece.
It's the hardest part of the graph.
It is. It is. I graph it and then I look back to make sure it's touching all 3 pieces or all however many pieces I was given. Here, if I had touched, or let me think about what I just said in terms of this one. If you graphed 1 over x squared, y equals 4, x equals 5.
Well, it didn't say anything about the x or y axis, so not the problem.
Yeah. But what I said wouldn't be sufficient just to make sure that it touches all 3 of those, because beneath that curve would have touched all 3 of them. But you're right, it didn't say anything about bounded by axes. All right. What else?
18 part B.
18B. Hello, sir.
Or D.
Oh, D.
Are we gonna have to find exact values of volume and stuff?
I'm thinking about putting a few on there, maybe 2 or 3, that you do have to find an exact value, but I promise it'll be one of the integrals that we've been working with a long, long time. It's not going to involve inverse trig functions. It could involve 1 over x, which you've known since last year was natural log. It could involve the power rule, but it would be something that you should be very familiar with by now. 8.1, which we will begin Wednesday, is just a review of integration, because really in chapter 7, we've used the calculator for most integration, and we might have slipped on a few of our integration formulas. So 8.1 will review those. All right, 18, and you said part D. You know, y equals square root of x is a sideways parabola. And y equals 2 would be when x equals 4. And then x equals 0 is the y-axis. So I want it bounded by this piece of parabola, the line y equals 2, and the y-axis would be right there. Did you have the right part of that,
I
Shayla?
have the right.
Okay, good, good.
I tried to use the shell method.
All right.
and I
It's
was kind of confused on how to get the p of x and the h of x just a little bit.
I think I did the disk method, so let's see if we could figure out if it could be done shell method as well. The D part is about the line x equals -1. So flip it across that line. And if you were using the shell method, then you would want vertical rectangles because they would be parallel to that vertical line. All right, so if we were using vertical rectangles, we need two things. We need the distance from the representative rectangle, wherever the representative rectangle is, the distance between that and the axis of revolution. So how do you get the distance between x and -1? It's 1 unit past just x going to the left. It's 1 unit past the y-axis, so it's not just x, it's x plus 1 more unit. Or you could think of it as x minus -1.
So if it's on that side of the y-axis, that's when you need to add.
You're subtracting a negative. You subtract to find distance, and subtracting a negative is the same as adding. Yeah, so that p would be x plus 1, and then the height of the rectangle would be, what did you have for that?
2 minus root x.
That wouldn't be bad with a calculator doing the integration for you. Yeah, it wouldn't be terrible to do by hand. The volume would be 2 pi times the integral from, what did you use for your bounds of integration?
From 0 to 4.
Okay, because that rectangle is sliding from here all the way over to there, 0 to 4. P times h.
When I plugged that in, it worked. I was a little concerned as to where the plus 1 came from, but now I understand.
Okay.
Minus negative.
And again, I did the disk method, and let's just make sure we can do that too. If we were using the disk method, we would want horizontal rectangles because they would be perpendicular to that axis of revolution. And when we use the disk method, we need the outer and the inner radius. So the outer radius and the inner radius, and then volume would just be pi times, if we were integrating, if we had horizontal rectangles, then the width would be dy, would be integrating y values from 0 to 2. What would be the outer radius of that thing swung around the line x equals 1? What's forming the outer radius?
Square root of x plus 1.
Because the whole thing is 1 unit wider than just square root of x. Square root of x, wait, no, not square root of x, because if we're using horizontal rectangles, we want our integram to be in terms of x, we'd need to use x equals y squared. So you were thinking the right thing. You were thinking add 1, but make sure you're adding 1 to this in terms of y. So y squared plus 1 is the outer radius. And then what's the inner radius? The hole that's being bored out. This was actually supposed to start right there. There's an empty place here, the radius is 1. So by the disk method, we'd have pi times the integral from 0 to 2, outer radius squared minus inner radius squared. dy. Oh, no, didn't tell me to move that up.
So if you're moving it about a line other than like the x or the y axis, you're always trying to account for the distance
Yes.
between that line and whatever.
Yes, absolutely. Because if I'm not good at picturing what it's going to look like 3D, but I can tell that the outer radius is more than just square root of x or x equals y squared. The outer radius is going to be bigger than just that. The inner radius is going to be, outer radius is going to be this big. And then you're going to bore out that little 1 unit piece in the middle. All right, what else? Can be anywhere, 7.4 or Chapter 7 review or 22 problem worksheet.
On the volume of solids revolution, like on numbers like 16 and 18, is that what you mean by you're accounting for the distance because since it's below the line?
Oh, the worksheet, 16 and 18 on the worksheet.
They're pretty much the same. Since they're below the line of rotation, is that what you mean by like your account for the distance it is?
Okay, it took me a minute to get where you were. Yes, on number 16, that's being revolved around the line y equals 8. So the outer radius, well actually I used the shell method. I used horizontal rectangles on that. So when you're using horizontal rectangles, your rectangle sliding from 0 up to 8, and that's your bounds of integration. And the distance between, let me think, P is the distance between the center of a rectangle and the axis of revolution. So as this slides up, the distance between the center of that rectangle and the axis of revolution would be 8 minus y. And the height of the rectangle would be left boundary minus right boundary in terms of y, not x. So left boundary is 2, right boundary is square root of y over 2. So the height of each rectangle is 2 minus square root of y over 2.
So if you were to do a washer, you could just, like, the outer radius would be 8 minus 0, and the inner radius would be 8 minus x squared.
Yep, the outer radius would just be 8.
Because that's the farthest thing from the line of rotation. That's
Mhm.
the outer radius.
Yep. And you said 18's like that as well?
I think so.
I used this method on number 18. What did you use?
I need the washer.
Yeah, disc washer. The distance between, no, I'm using this method here. The outer radius would be this horizontal line, y equals 6, the axis of rotation, minus this. That's what's whipping around and creating the outside of the disc. And then the inside of the disc, the part that's being bored out, is 6 minus this piece. So that would give you this is empty.
I wrote my integral different, still got the same answer.
All right, let me write down what you got and see if I can justify why that should give you the same answer. This is 18 on the worksheet. What did you have?
Wait, then my other, can I see yours?
Yes,
Never mind. Oh,
it's the same?
Yeah,
Okay,
I don't know what else.
all right, what else? I didn't get the test made this weekend. My greatest concern is few enough problems that you can finish, but enough problems that they're not worth a letter grade each. I don't like giving a 10-problem test. Yeah, I don't like that. So when I was trying to think how I could get more parts in there without adding more time, I think it's let you do several things with the same graph. Because the graphing and figuring out what to shade is a big time eater. So if I can find one graph and let you use the disc method, the washer method, find some area, find an arc length, all with that same graph, then that will save you time. The parts of the problems may end up being more than 5 points. They may be 7 points. If I can get 14 problems, I think you can get done in an hour and a half. That'd be 7 points each. I will come in at 7:30. Nope. Yes, 7:30 to give you an hour and a half to work on it. I'll be here at 7:30. What else do you want to see? I'll be very clear in my instructions about if there are a couple on there that I want you to do the integration by hand, I'll say do integration by hand, show your work. On the other problems that I've already started and have on the test, I said give the exact answer from your calculator. So you just get the definite integral part and then stick a pi on it.
Will arc length and surface area always be binary?
No, especially if I'm using some piece of some other graph that you've already evaluated an integral on the calculator. No, there will be probably 3 that you have to do by hand, 2 or 3 that you have to do by hand, but they will be integrals that you should be very familiar with. I feel like substitution is fair game now, but not inverse trig functions. I still don't have those memorized. Or I memorize them for a day and then forget them. What else do you want to see?
What was the thing where, when you're doing arc length, if it's like X, if it's around a Y axis?
Yes, yes, yes. Where do I have that note? Right here. This is my note in 7.4. When you're rotating a function around a horizontal axis like this, then the radius is going to be a y value, and the y value is the function. So the radius in this case would just be, where is it? Yeah, 2 square root of x. If you're revolving that around a vertical axis, then the radius is x. Yep. Dizzy, you didn't bring me a list?
Yes.
A list of stuff you wanted to see. I don't have anything else for us to do. I'm going to go back home and go to bed. You got in here late, you didn't hear. I got up at 3:30 this morning.
I'm sorry.
That's all right. We packed Mal and Philippe and their U-Haul off to Key Largo. They're gone. Yeah, I'm sleepy. I go back home and take a nap.
It's kind of one of
And then
those
wake up.
practice and practice thing.
It is. I still find myself I just have to go slowly and think because I'll make mistakes. And shading the wrong part, that's a common mistake. Not taking into account that you're not rotating just around the X or Y axis. Gotta watch out for that.
Will there be any involving use substitution before like in the interval?
Not formal U substitution. There could be one like if you have square root of x squared plus 1, and then you got a 2x dx as part of the integral, then you're just integrating u to the 1/2. I feel like y'all should be able to handle that. Probably not one where you had to do formal substitution.
There was one on the chapter review that was great.
Yeah, and I didn't do the chapter review till yesterday, so if I ever get to teach Cal 2 again, number 27, that will not be on the practice test if I ever teach it again. What about number 29? Y'all figured out the surface area of a right circular cone?
Yeah.
Cool. I did too. I was proud of me.
How do you know which axis to make the inner radius or the radius and which one to make the height? Because on the Caltrax picture, the height was like the x-axis.
What they did, and I did mine without looking at CalCheck, and so I was really happy when I got the same answer, but they drew the cone rotating around the x-axis, and I drew my cone rotating around the y-axis, and that would determine whether you used y equals 4/3 x or y equals 3/4
You
x.
should get the same
Yes,
answer.
yes. What did I say that was number 30?
29.
29. And I've got my pages get all mixed up. There it is. 29. Yeah. I did make a mistake at first. I made a right circular cylinder instead of a cone. But then I realized, hey, that's not what they're talking about. And I used y equals 4/3 x. Actually, I rotated it around the line x equals 3. If it said height of 4/3 and radius of 3, I started at 0, 0, went up 4/3. Equation of that line would be y equals 4/3 x. And then to make a cone, I rotated it around the line x equals 3. You got the same thing. Anything else?
The one after that was a lot easier because like you knew what the picture.
Oh yeah, yeah.
Do you have a rough estimate about how many times we're gonna have to complete the square test?
Make sure, because there aren't a lot of problems for me to choose from that have x in terms of y. So one of the big things that, as I was thinking about what problems to put on the test, I wanted to make sure that you could graph a parabola, a sideways parabola like that by completing the square. That's the only time I could think of that you should have to complete the square. And I remember a problem from somewhere, it was just a little bit uglier than that. It was something like x equals negative y squared, let's say plus 6y. just for the heck of it, minus 12. Well, let's make it minus 18. How would you find the vertex of that parabola if you had to?
2 and square and add on.
I would probably factor out a -1 just out of the first two terms, and then figure out what to add to complete the square. Take half of 6 is 3, square it is 9. Add 9, but remember that everything you've added inside parentheses is really multiplied by -1. So you really haven't added 9, you've really subtracted 9. So, yeah. To make sure that's equivalent to the line above it, just look, redistribute that -1. You'd have the negative y squared, you'd have the plus 6y, and then you would have minus 9 plus 9 is 0. And there's your minus 18. So that's equivalent to the line above it. And that factors into -1 times y minus 3 squared minus 9. And then be careful with the vertex. It is the opposite of the guy in parentheses and the guy on the end. But in what order is that ordered pair? What's the vertex of that sideways parabola? Yeah. The 3 is with the y, so it's the y coordinate of the vertex.
Wouldn't that be negative?
Wouldn't that?
-1 that you need to distribute.
No, the -1 tells you that it opens to the left, but the vertex is the opposite of the guy in parentheses. Always. So when I was looking at problems yesterday, Chase, I was concerned about y'all being totally okay with that. But now that I've reviewed it,
Yeah.
make sure you can find the vertex of a sideways parabola. And that's the only time I could think of you'd need to complete the square.
So it's the opposite of what sides that's inside parentheses and then whatever's on the outside.
Yes, the equation would be a times y minus k squared plus h. The a tells you whether it opens left or right. But the vertex is hk. What else? I can Google one for 5 bonus points.
Will you look at number 19 on the worksheet you get?
Worksheet number 19.
Because I completed the square and I had, it was like negative x minus 1 all squared. And I have the vertex at -1. Okay, it looks similar to what we just did.
Okay.
The negative outside the parentheses.
All right, let me just catch up with you. Number 19. And so you're not talking about the whole problem, just graphing that sideways parabola?
Yeah.
All right.
What sideways?
Oh, you're right. You're right. It's not sideways. If they're not sideways, I usually just use negative b over 2a. But if I do want to complete the square, then I'd factor out a -1. And what did you add inside the parentheses to complete the square?
1.
And then you said, I didn't really add 1, I really subtracted 1. So you added 1 to that 6, right?
I had a sign mistake.
Oh, okay. plus 1 squared plus 7. So what's the vertex of that parabola? Negative 1, 7.
Yeah, that sounds good.
Okay. All right. Anything else? All right. I might find 2 problems, 3 points each. Give you 6 bonus points for this test.